So now we're on logarithmic form 2, which is very similar, just with fractions and negatives and stuff like that. So it's a little bit more complicated, but we can still totally do it. Same process. So let's rewrite this as an exponential. 49 is our base. The exponent is -3/2. And this is equal to x. So we got to figure out what x is. So essentially, what is 49 to the power of -3/2? Well, let's deal with the negative first. Okay, so the negative in our exponent really means we want to flip this fraction. Technically, right now, it's a 49/1. So if our fraction right now is 49/1, to take care of the negative, I'm just going to draw an arrow. This is our next step. Instead of 49/1, we want 1/49. So we just flip the fraction, and that takes care of our negative. So now it's 49 to the power 3/2, and it's on the bottom of the fraction this time instead of the top. Okay, so that took care of the negative in the exponent. Now let's deal with the fraction portion in the exponent, the part where it's over 2. So that part where it's divided by 2, that's actually the square root. So I'm going to go over here. I'll just write it underneath. We want the square root of 49. Sorry, that just says 49. I know I wrote it on top of this stuff. It's not very neat, but if I make it bolder, is that uglier or more visible? I have no clue. But the part where it says over 2, that's the square root. Okay, so instead of a fractional exponent now, we just have the square root of 49, which we can totally calculate. So we know that the square root of 49 is 7. So let's take care of the square root of 49. That becomes 1/7 to the power of 3 equals x. And so finally, now we can figure out what 7 to the power 3 is, and then we can do that on your calculator or whatever it is in your head if you are like that. That's fine. And 7 to the power 3 is 343. So your final answer for x is 1/343. So this is our final answer. So there were a lot of things going on here. There was a negative, there was a fraction. So are there any questions? Okay, so then I'm going to type in 1/343, and let's submit. Okay, let's go to the next problem. Let me clear all those ugly annotations. Okay, so we're going to solve for x again. So this time our base is x to the power of -6/5 equals 1/729. Okay, so this time it's a little bit more complicated because it's like we don't know what x is, and x is the base of our exponent. So what we can do is actually move the exponent over to the other side because we want to solve, like we want it to say x equals something. We don't want x to the power of -6/5. So the way we can do that is take both sides and raise it to the power of the reciprocal of this. So instead of -6/5, I'm going to now raise this to -5/6. -5/6, both sides. And so you might be wondering, why in the world are you raising it to the power of -5/6? Like, why do you flip the fraction around and just raise both sides to that power? So here's why. When you have two exponents like this, where one is raised to the power of the other, you're just going to multiply these, right? So technically, it should be x to the power of, let me write it out, x to the power of -6/5 multiplied by -5/6. So I'm just going to show the work here. We're just multiplying these because that's the exponent rule. Is equal to 1/729 to the power of -5/6. Sorry, that's messy, but there you go. So all I did right here is just rewrite it so that we're multiplying those exponents together. Those exponents being the ones I circled in yellow. So we're multiplying those together. And what happens when you multiply reciprocals? They're going to cancel each other out. The negative will cancel with the negative. Let me cross this out in a different color. The negative will cancel with the negative. The 6 will cancel with the 6, and the 5 will cancel with the 5. So all you are left with now is x equals 1 over 729 to the power of negative 5 over 6. So that's why we multiply by the flipped fraction, the reciprocal of this one. We multiply it by a reciprocal so that everything can cancel out, and then we're just left with x equals. So now all we have to deal with is the 1 over 729 to the power of negative 5, 6. So we're going to continue this problem in just a moment, but this was like a kind of new concept, so I want to pause and see if you guys have any questions up till here. All right, so now that we know we have to deal with this portion, let's first deal with the negative. I like dealing with the negative first. So then I'm going to continue over here because it's where I have space. We have x equals, remember the negative part means you're going to flip the fraction. So now instead of 1 over 729, we want 729 over 1, which is technically just 729, but I'm writing it over 1 so to emphasize that it's a flipped fraction. And that takes care of our negative. So now we just have it to the power of positive 5 over 6. Okay, so now let's deal with the fact that it's a fraction. It says over 6. It's 5 over 6. So that means we want to take the 6th root. The 6th root of 729. And then we're going to raise that to the power of 5 later. But instead of dealing with gigantic numbers, let's take the 6th root first. It makes it a lot simpler. So of course, if you don't know what the 6th root of 729 is, you just try it on your calculator. Is it 1? Okay, not 1, but like, is it 2 to the power of 6, 3 to the power of 6? Which one is it? So if you try it out, you will find that 3 to the power of 6 is 729. So this portion becomes 3, and then it's still raised to the power of 5. And so the last step is just to figure out what 3 to the power of 5 is, and it's 243. And so our final answer is 243. So that was also quite a few steps, so I want to just pause here to see if anybody has any questions. And then I will type in 243. Oof, look at all that mess. Okay, and then let's go to the next problem. I think we can do maybe 1 or 2 more. We'll see. I mean, actually, I'll just do 2 more because it can't hurt to have more examples, right? If you don't need the examples, then you're probably already doing your work anyways. So, all right, so let's rewrite this in exponential form. We have a base of 27. We have an exponent of negative 5 thirds, and this is going to be equal to the value of x. We have our base, our exponent, and our value. And luckily, it already says x equals. So all we have to deal with is the 27 to the power of negative 5 thirds. So once again, I said I like dealing with the negative first. You can deal with the fraction first, the negative first. You can raise it to the power of 5 first. It doesn't really matter what order you do it in. But personally, I think it just makes it easier to deal with the negative first. Just personal preference. But you can do it whichever way you want. So I'm going to deal with the negative first. Remember, the negative means flip the fraction. So technically, we have a 27 over 1. So now we're going to turn it into, I'm just going to do it this way. We're going to turn it into a 1 over 27. And so this takes care of the negative. Now we have it to the power of positive 5 thirds. After we take care of the negative, I like to take care of the, what's called the fraction. So let's take care of the fact that it's over 3. Fine. So the fact that it's over 3 means we want a third root of 27. So it's still 1 over. And then the fact that it's over 3 is the third root. And then we're going to raise that third root to the power of 5 eventually. Okay, so we have 1 over the cubic root of 27 to the power of 5. What is the cubic root of 27? Let me write that over here because it's where I have space. The third root of 27 is 3. So we have 3 to the power of 5. And that's equal to x. And isn't that like the same thing we just did? 3 to the power of 5? Yeah. Okay, well, 3 to the power of 5 is 243. And so this is our final answer, 1 over 243. So I'm going to pause here, see if you guys have any questions. So I'm going to scroll and enter in 1 over 243. Okay, let's do another one. Once again, if you don't need the other examples, that's totally fine. You can just be working on your own. But I'm doing examples for other people who may or may not need it. Okay, so we have a log with a base of 4. And then our exponent is the negative 1/2. Then our value is x. Okay, so once again, let's deal with the negative first. So technically this is a 4 over 1. Let's flip our fraction. Now we have 1 over 4. Well, I guess I don't want to write it like that. But 1 over 4, and then now it's a positive 1/2. Okay, and so let's deal with the fact that it is divided by 2. Divided by 2 in the exponent means you are doing a square root. So this is going to be 1 over the square root of 4 to the power of 1. And then, well, what is the square root of 4? The square root of 4 is just 2. So this is x is equal to 1 over 2 to the power of 1. But we know that anything to the power of 1 is itself. So this is 1 over 2, final answer right here. This one was a little bit shorter because we have smaller numbers to deal with, but the concepts are still the same. So let me know if you have any questions. All right, so let's see. 1/2. Okay, I'm gonna just look for that specific type of problem. So let's see if they give it to us. Next problem. No, that's not what I want. This is what I want. Okay, cool. So let's clear these annotations. And let's rewrite this out. So we have x is our base to the power of negative 2 is equal to 1 over 36. So notice that x is our base and x has an exponent to it. So it makes it a little bit harder, but what we can do to solve for x is raise both sides to the power of the reciprocal of this. And you might be thinking, that doesn't look like a fraction. How do you reciprocate it? It is a fraction. It is negative 2 over 1. So to reciprocate that, you just flip it around, negative 1 over 2, but still negative, okay? So we're raising both sides to negative 1 over 2. And we do this because when we reciprocate the fractions, when you multiply them together, it's going to cancel each other out. And so remember that when you have these two exponents like this, you're going to multiply them. So let's do that. I'm going to show the work for it. You don't have to show it when you're doing your homework problems, but this is the reason why. So since it's the reason I like showing why, you're going to multiply that by negative 1/2. That's a 2. There we go. Is equal to 1 over 36 to the power of negative 1/2. Okay. So those two yellow circled fractions get multiplied together, and then so let's cancel stuff out. The negative cancels with the negative. The 1s technically cancel with the 1. The 2 cancels with the 2. So this is just x. It's x to the power of 1, and that's why we multiply by the reciprocal, so that it could just be x. So x is equal to 1 over 36 to the power of negative 1/2. Oh my goodness, half. Okay, there we go. So now all we have to deal with is the 1 over 36 to the power of negative 1/2. And in my typical fashion, let's get rid of the negative first. And the negative means we're going to flip the fraction around. So instead of 1 over 36, it's now 36 over 1, which as you know is 36. But I am writing it as over 1 to emphasize. And this is now raised to the power of positive 1/2. Okay, and so now I like to deal with the fact that it is a fraction. And so the fraction means over 2. Over 2 means square root. What are we square rooting? 36. Technically 36 over 1, but 36. And then it's to the power of 1. I'm just writing it here for emphasis. And then the square root of 36, you guys know, is 6. So we have 6 to the power of 1, which you guys know is 6. So now I get to pause it and see if you guys have any questions. Okay, so let's type in our answer, which is 6. And then let's end the video.